Okay, folks, this example here, here we go. You can see that you have the function. It's the derivative. It tells you it's twice differentiable, which means it's very nicely behaving. It says you have horizontal tangents of -1, +1, and a 3. That means you have local min, local max, local min for f prime at those spots. And then it tells you that the area here is exactly 9 and the area here is exactly 12. So let's start with question A. Question A says find all x coordinates where you have a relative maximum, f. Now this is f prime, we're considering f. So look for f prime to change. Remember, if you have a relative maximum, that goes from increasing to decreasing. Look for f prime change from positive to negative. Where does f prime change from positive to negative? Changes here at -2. This happens at x equals -2. Good. B says, on what open intervals, -3 to 4, so -3 to +4, is the graph both concave down and decreasing? Well, concave down is where f double prime is negative. Decreasing is where f prime is negative. So if we look here, where is f prime negative? F prime is negative from -2 to 4. But where is the second derivative negative? That would be where f prime is decreasing. So the derivative of the derivative looks like it's negative here and it's negative here. So from -2 to -1 and then from 1 to 3. That's both where f prime is negative and where your second derivative is also negative. So -2 to -1 and 1 to 3, we're going to say f prime is negative and f prime is decreasing. That's a way of talking about the f double prime being negative. This one is headed down. That means that this is negative. Okay. Letter C, find x coordinates of all points of inflection. Inflection happens. Look for where f double prime changes sign. Well, that's where f prime goes from increasing to decreasing, or f prime goes from decreasing to increasing. So let's look at f prime. It changes from decreasing to increasing. It changes from decreasing to increasing. So we have -1 and 3. And it changes from increasing to decreasing at 1. So f prime changes from increasing to decreasing at x equals 1. And f prime changes from decreasing to increasing at x equals -1 and 3. Inflection occurs at x equals -1, 1, and 3. I don't know if I spelled occurs right. Sorry about that. And finally, letter D. Given that f of 1 is 3, so not this, if you look at 1 is 0, the original function is equal to 3. Write an expression for f of x involves an integral. So it's kind of tough to kind of think about here, but it's this whole idea of position equals start plus displacement. That's what we're thinking of in this scenario, okay? So that means when it starts at 1, it has a position of 3, and the integral is that displacement thing. So f of x, the placement of the function, is equal to its start, which is 3, plus that integral beginning at 1, wherever it stops, of f of x dx. Okay. Now, the fact is that I think that they actually use, f prime, the rate function there. So that's what we have. So we're wondering about f of x. We take the integral or the antiderivative of f prime to get f. So we have that, okay? And now we're going to use that, okay? And it says find f of 4. Well, that's going to be equal to 3 plus the integral from 1 to 4 of f prime of x dx. And it told us that the integral from 1 to 4, that area right there is 12. So f of 4 is equal to 3 plus, not 12, but negative 12. I would have made that mistake. I looked at the answer key. Why is it negative? Because it sits below the x-axis, so therefore they had a negative value there. So that is equal to negative 9. Then f of negative 2 it asks us to find. We'll do 3 plus the integral from 1 to negative 2 of f prime of x dx. Okay. Now what's interesting here is you can see they want you to recognize that you have a flip of the signs. So we can do 3 minus the integral from negative 2 to 1 of f prime of x dx. So look at the area from negative 2 to positive 1. And this area here, it says is 9 because it's below the x-axis. We would call that negative 9. So we have 3 minus negative 9 is equal to 12. I'll admit, folks, the negative would have caught me. I just would have wrote the regular areas. I would not have thought sitting under the x-axis in that situation. So every once in a while it gets the teacher as well. So there you have it. There's another one for you. We'll check out another one here in a second.